Okay, now in the last class we have discussed the gyroscopic effect and we have derived the equation for the gyroscopic torque, and the equation has been I omega omega p. And now we will be discussing how to determine the direction of that gyroscopic couple. Now as you that we have a two-wheeler, and the two-wheeler or the rider is riding this vehicle in a direction like this. So if you are looking from your side, it can be seen that we have wheels, and that wheels are rotating, and the axis of rotation is this. This is the direction, or this pen will represent the direction or the axis of rotation of this wheel. And this direction we usually call it as the Z direction. So it is perpendicular to this plane, this axis is perpendicular to this plane, and we can call this axis as the Z axis. And when you are looking from your side, you can see that the wheels should be rotated in clockwise direction. The wheels are rotated in clockwise direction. And if the wheels has to be rotated in clockwise direction, there should be an angular momentum, and the angular momentum vector should be acting along this axis. And this axis, I call it as the axis of spin or spin axis, or it is the axis on which this wheel is spinning. And as this wheel is rotated in clockwise direction, and if you are looking from your side, according to right hand screw rule, you can say when the screw has been rotated in clockwise direction, the screw will be moved away from the operator. That means the angular momentum vector of this spin should be directed along Z direction, and it should be away from you. So that if I am removing the top of this pen, this nib or the tip of this pen will give the direction of the angular momentum vector. So it is acting along Z direction, and it should be directed away from you, or it is directed towards me as I am looking from this side. So that this tip now represents the direction of the angular momentum vector of spin. And assume that this wheel has been spinning at an angular velocity of omega. So the axis of spin is this. This is the direction of the angular momentum vector, and the angular velocity of spin is omega. Now assume that this vehicle is taking a right hand turn like this, or it is turning towards you, and you can say that you are staying inside that curve. Now the vehicle, as it initially has been moving like this, now it takes a right hand turn, or it has been turned towards you. So that if you are looking from your side, or if you are considering this angular momentum vector or the axis of spin, this has been the axis of spin. Now when the vehicle turns like this spin axis will now be rotated like this. Will be rotated like this. And this rotation can be observed if you are looking from the top. So that if you are looking from the top, this rotation or the spin axis has now been rotated in clockwise direction. So clear? The spin vector is now rotated in clockwise direction as we are looking from top. Or otherwise we can say this spin vector or the spin axis now has been rotated with respect to this vertical axis. But this vertical axis we usually call it as y-axis. So the spin axis, which has been initially the z-axis, is now rotated with respect to the y-axis by an amount like this. And assume that this angle has been d theta, or the spin axis has now been assumed to be rotated by d theta. And assume that this takes place, or this turning takes place within a time interval of dt, a small interval of dt. So that if you are looking from top, you can see that the spin axis has now been rotated in clockwise direction by an amount of d theta. And the direction of rotation, or the rotation, has been with respect to y-axis. So the spin axis, which has been the z-axis, is now turned with respect to a vertical axis y by an amount of d theta, and this action of rotating the spin axis with respect to a second perpendicular axis, it is called as precession. That operation is called as precession. And here we can say the spin axis has now been precised by d theta, by an angle d theta, and that takes place within a time interval of dt. So that the d theta by dt will now be called as the angular velocity of precession and can be represented as omega p as given in your note. So this d theta by dt is called as omega p. So here we have a spin axis. For this instant I am assuming that the spin axis has been the z axis. Now the spin axis has been precised with respect to y axis. So that this new spin vector or the new angular momentum vector of spin will be like this, which is inclined angle of d theta with the initial z axis. Now this vector will now have two components, one acting along the initial z direction and one perpendicular to this z direction. And we are interested on the vertical component of this. So this component, this new angular momentum vector can be resolved into two components, one acting along the initial z direction like this and one perpendicular to the z direction. So that the second component, that is the component perpendicular to this new angular momentum vector, will be like this. So clear? This will be that vector, and this vector is now directed along this direction. It is directed along x direction. So this is the x axis. So the component of this vector perpendicular to this initial spin vector has now been taken, and it will be acting in a direction like this, and this is the x direction. So initially spin axis has been z, it has been precise with respect to y axis, and we have a new component of angular momentum vector acting along x direction. And if this has to be accelerated in a direction like this, it should be acted upon by a torque, and we have already obtained that this acceleration along this direction will be given as omega into omega p, and that equation has been derived in the notes that has been circulated yesterday. So this angular acceleration along this direction will be omega into omega p, and if the spinning wheel has got a mass moment of inertia of I, the torque required to cause this acceleration should be I into acceleration or I into alpha, or otherwise it should be I omega into omega p. That means there should be a torque applied with respect to x axis, and that torque should be I omega into omega p. Then only this spin axis, which has been originally z axis, can be precise with respect to y axis. Or if this spin axis has to be precise, then there should be a torque applied on that object, and that torque should be applied with respect to the third perpendicular axis. Angle of spin, if it is z axis, and the angle or if the axis of precession is y, then the new torque axis should be x axis. And moreover, it can be seen that the direction is like this. So it is along the positive x direction. So the tip represents the direction. Tip of the spin represents the direction of that torque. So that torque is the active torque which is required to precess this axis of spin. And the torque, the magnitude of the torque is I omega into omega p. So that this is the active torque, and it is called as the gyroscopic torque. So the magnitude of the gyroscopic torque is I omega into omega p, and has been directed like this. But we can say if the machine has been acted upon, or if the machine is to be acted upon by a torque like this, it will be producing an opposite effect, which is the action and reaction, just like we have the centripetal component of force and centrifugal force. Centripetal component of force and centrifugal component of force. So here we can say the active torque should be like this, so that that machine should be acted upon by a reactive component. So that what should be the direction of the reactive component? It should be just opposite. That means it should be acting along x direction, but it should be directed towards me as I am looking from back of this vehicle. So that if this is the vehicle, and if I am looking from the back of this vehicle will be acted upon by a torque which should be acting towards me, or the angular momentum vector should be towards me, and the angular momentum vector should be towards me means this object should be rotated in anti-clockwise direction. Should be rotated in anti-clockwise. So if it is rotated clockwise, it will be away from me. But as it is towards me, it means that this body should now be acted upon by a reactive gyroscopic torque, which should be anti-clockwise as I am looking from back. And if this is acted upon by an anti-clockwise torque, what happens? This vehicle will be turned like this, or this vehicle will now be turned like this. It will fall away from the center of curve. Will be falling away from you, or otherwise the vehicle should be falling away from the center of curve like this. So this produces an anti-clockwise couple. And the effect produced on this vehicle, it is called as the gyroscopic effect. So the gyroscopic effect on this vehicle, when it moves in a direction like this and takes a right turn, will be to cause a torque which causes this vehicle along with the passenger to fall in a direction like this. It will fall away from the curve. And the torque which causes that, the magnitude of the torque which causes that falling effect should be I omega p, which is called as the gyroscopic torque, or this is gyroscopic effect.